All right, so last time we started off with basic directional control valves. This time we're going to be talking specifically about the hydraulic directional control valves. All right, so before we kind of get into that, what are some of the ways that we identify directional control valves? Not generally labeled. Yes, I'm asking how you would identify it. So this one right here. It's not just that. I think this is very oily. Let me get a girl here for a second. That's oily. Yuck. Okay. This is a directional control valve. Not only is it a directional control valve, this one is a 4-3 solenoid controlled spring center. Now I do know that because it is imprinted upon it. That's the tag. But the way I need to identify it, or pass it around. Or y'all can come up and just look at it. So if you look at this at the bottom, I have 4 ports. 1, 2, 3, 4. Okay? That is being controlled by these 2 solenoids. The springs are internal. And the reason I know it's got 3 positions is because this right here is telling me it's got 3 positions. So when looking at this, were I to redraw it, what do each of the boxes mean? The number of positions. Okay, it's the number of positions. This one has 3. Okay. The next thing I'll put on there is my number of ways or ports. Generally, if you look on these, it will either label them as A, B, P, T, port A, port B, pump, tank. The second it'll do is show you what each of the other positions will do. So what this means is that when it's actuated to this position, your pump will go to port B, your port A will drain to tank. The other thing, if you have it actuated, if you have it actuated the other way, pump goes to A, B goes to tank. Y'all follow? So that's what we're looking at. We're going to start off looking at our center square. We have 3 positions. We look at the centermost in this case, and we say there's 4 places where something is touching the edge of that box. Guess with me. Okay. Next thing we got to talk about is how is it actuated? How is it moved? In this case, it's solenoid controlled to both sides. And lastly, and this is something that is generally only found on 3 positions, it's called a spring center. Having those springs to either side means that when no pressure is applied, it will center itself to the center. Okay? Now, I don't mind passing this guy around. Just be careful, he's a little heavy. This is an actual double solenoid spring centered 3-position 4-way. Which means in order to actuate him, I have to use electricity, and that is wrapped with a copper wire around an iron core. Okay, that core is magnetized, so whenever you run a current through it, it's either going to attract or repel, depending upon which way that rod is set. Okay. So we identify these valves 4 ways. We identify them by how many positions they have, and by that we're looking at these boxes. We're identifying them by the number of ports. In this case, we're looking at how many times does the symbol touch the edge of the box. And the 2 last things we talk about are what are they actuated by. Okay? What are they actuated by? What do they actually show us as actuation? Okay?
Hey, Ms. Bush, I'm on.
So the number of connecting ports, they are never less than 2, and you rarely see them greater than 5. And 5 generally goes towards pneumatics more than hydraulics. Why? Because it's just an extra exhaust port. With hydraulics, you generally have 4 ports or less. Okay? 4, 3, or 2. That's the most common ones. You can have 5, but it's just another exhaust port. The next thing you got to look at is the number of control positions. Okay? Now, with control positions, it says that there's 2 or 3 positions. There are instances where you will only see 1. Where's my book? I want to draw this right. Alright, so if I draw something like a relief valve, okay? Okay, so that is a relief valve. I'll say it's a great picture of it, but it is a relief valve. So what you have here, you have a pilot line that's coming around. Now we'll be dealing with pilot lines soon. Pilot lines are a way to take lesser pressure, either hydraulic or pneumatic, to actuate something over. In this case, what we're looking for is if my pressure in my system becomes too much, excessive pressure causes this guy to shift this so that all the pressure will just drain the tank. Okay? Any excess pressure will be drained off. Okay? How many of y'all use your garden hose pretty frequently in the summer? What happens if you don't release the water periodically? tears in it, leaks around all your seals, everything drips, nothing really seals, right? The same thing happens with hydraulics. Exactly the same thing happens with hydraulics. So we have to put in relief valves or else we would be perpetually running very leaky systems. Anybody want to deal with a hydraulic leak? It's a very big mess. It's a very big, very gross mess. So what we do instead is we put in pressure relief valves. So any excessive pressure just immediately drains off. It doesn't stick around. That is the only instances like this where you're going to see a single position because it's just actuated by something outside it. It will not come into play unless something major is going on and you have a backup in the system. Normally, you will see 2 to 3 positions. Okay. So we talked a little bit about this last time. You're going to look at the number of connecting ports, the number of control positions, the method of operation. That's what these are. How are they operated? The one I just showed y'all, electrically operated. They can be mechanically operated. That's that cam valve you'll have, right? You have manual operation. How many of you, it's just where you push the button or flip the switch. That's manual operation. Or you have what's called pilot pressure. Y'all have seen this before in those pressure valves, those long little silver valves in your trainer. Those are pneumatically actuated. What that means is that they take a separate pneumatic source and they use that to move themselves. Okay? They quite literally use that to move themselves whenever they're given that signal. Okay? Lastly, when it comes to hydraulics, we have another way of looking at them, and it is in the book. It's down at the very bottom of page 3, and that is the different centers. We have a closed center, an open center, a tandem, or float. We'll talk about those here real quick. Okay. So kind of a similarity versus difference. You're going to have the same number of ports, the same number of control positions. Everything is the same, except that pneumatic can get by without a basic center position to always go back to. With hydraulics, we really have a problem with that because if we don't have some way of directing that pressure and keeping that pressure under control, you have a really bad issue with your system. Okay? So there really is not much difference except what a center position will do. Okay. So a closed center. A closed off center position. What that actually means is that there is no flow. You look at the symbol, you can see there is no flow. Okay? Everything's capped off. What that means is that any pressure at any of these ports is going nowhere. Okay? It just isn't going to do anything. It's not going to do any work. It's just going to sit there for a bit until you push it either way. It also means that there is no drain to tank. Okay. You have an open center, which is exactly what it sounds like. It means basically that any and all pressure is flooding to tank because that's where all the circle of this is going to end. make sense? So everything's going to tank whenever you're doing this. Because you're not really maintaining pressure. Basically, you've created an open suction line at tank. Everything's just going to go over the tank. And it's gone. You have what's called a tandem center. So what this is going to do is it's going to lock whatever is attached to this. So if I have a actuator, okay? I have an actuator, right? What this is going to do is if this is extended, it will stay extended. If this is retracted, it will stay retracted. It will not be able to move. Now, if you look at this previous one, you don't have any pressure holding this in place. So if you have that actuator attached to it, you can move that pretty easily. You can literally just take your actuator and move it very easily. Means that it has no way to hold position. How about that? There's no way for this guy to hold his position. Versus a tandem center, where this guy will lock. He will hold position until kingdom come. Does that make sense? What you should also note is that all your pressure is venting to tank. Now, let me make something clear here. Tank is not so much a suction line as it's just a drain line. Because what is it doing? It's draining everything off to the tank. By tank, I mean the actual tank, just like you have an oil pan in your car for your oil. Right? You all know what I'm talking about. Yeah? It's what they change, it's what they clean out whenever they change your oil. For those of you that didn't know. Everything is going to tank. Why? Because it's oils, and we don't want that like running around everywhere and running out everywhere. So all pressure is venting to tank, which means that there is no excessive pressure on the system should you need it. You know, we don't have a high pressure situation, we have a system pressure. And then we have what's called the float center. And this is not all the configurations. If you look at this one that I drew up here, okay? Same thing. What this means is that any and all pressure that is in your cylinder, this guy right here, any and all pressure is being pulled out and sent to tank, which means this guy is very freely able to move. He has nothing holding him still. Does that make sense? So there are some other iterations. This would be another tandem center where pressure is kept on both sides of your cylinder. Now what that would mean is that whatever position he's in, what's he going to do? He's going to be locked there, right? Because while pressure is maintained at both ports, whatever port was last in use is going to have the most pressure on it already. You're just adding more pressure to that. What about this guy right here? What's going to happen? Let's say port A is this guy right here, the one that extends. What's it going to cause him to do? It's going to be sucking it back, right? It's going to pull all that fluid out. All right? The same thing will happen for the next one. And then lastly, this guy means that pressure is going to be held to A no matter what. The tank is capped off. and B is capped off. No, closed means that everything's closed off. Does that make sense? Closed means that there is no movement from anybody anywhere. Open means that everybody's open and draining. And then you have the tandem and float centers, which okay. So those are the different centers that you will see with hydraulics. Like I said, it's not a guarantee that any of them will be exactly what they are, but it will be what they are. Now, all that being said, what are the 3 ways I identify a valve? What are the main 3 things that are going to be the identifiers for a valve? All right.
Would it be like in connected to something else, like a system of some sort?
We just went over this, guys. All right. I was trying to pull up an empty PowerPoint. Right now it's not letting me. What in the world is going on with this computer? Yeah. All right. So for the guys at home, we start off with what? What do the boxes here mean? It's the number of positions.
Yeah, number of positions.
Yep, number of positions. Okay. The next thing we identify with is the number of what?
How many paths?
How many paths or ways?
Yeah.
So I can make that off. All right, so this would be a 3-way valve. Okay. Probably should, not the best example of it, but just trying to kind of draw it up. And then what's the last way I identify it?
How many exits?
We've already talked ports. Ports are every time that you have one of these lines touch the outside of the box. They're called ways. They're ports or ways. You have position, and you have what?
The startup.
What causes it to move?
That's a
That's
spring
a really
valve.
bad spring. So this one's a push button, 2-position, 3-way spring return. Y'all see what I mean? If I was to draw another one, all right? I hate trying to draw with a mouse. All right, so how would I describe this one?
That would be a 3-port.
3-port.
I mean, I'm sorry.
It's not 3-port. It's what? 3 positions.
3 positions. Yeah, that's what I was trying to say.
The positions are how many different ways can I move this valve? The ports are how many different ways am I moving fluid? Or how many different exits that we're, or how many entrances and exits we're moving fluid through.
So it's a 3-position 4-way.
Yes.
With two spring valves. I mean, yeah, 2 springs.
The springs means it's spring centered.
Spring center.
So if I was to do this, this would be a 3-position. I'm going to put it as POS just because trying to write with a mouse is really not easy.
Positions, how many blocks that is now?
Yes. Okay, so you have position 1, 2, and 3. How many different ways can I actuate this valve? 3. You have the center, which would be if you let go. Actually, it should have 2 buttons on either side. So if I push one button, it moves it this way. So this would be my position right here. If I move this button, it moves the other way, and this is my position. But you have everything centered with the springs. So it is not the best way I could do this, but I don't exactly have any other way but a pen to write with. So we have a 3-position, 4-way, or 4-port, manual operated with spring centered. Okay, how I know it's spring centered is springs are on either side. Springs are on either side, you have 3 positions, and you're trying to keep it in that center position whenever it's not actuated. Okay? Yes, it's manual because it's got a push button on either side. And yes, I know it's not the best drawing, but drawing the mouse. That earns me some brownie points, right? All right, any questions on this, guys? And the other way you would actually call this is if it was hydraulic, way you would know would be that your arrows, these arrows right here, would be colored in. At which point you would also need to know what kind of center that is. In this case, it is a tandem. And I can't spell tandem. DEM. TANTEM. Tandem center. That kind of looks right. Trying to make it not look like an M. It's supposed to be an N. Tandem center. And that is because it is hydraulic. And that is the way we identify hydraulic centers. Okay? So any questions on this, guys? No? All right. So I'm going to go ahead and erase this. I'm going to ask y'all again. What are the main 3 ways? I'm sorry. What are the main 3 ways that we identify a valve? So we'll do them actually bulleted here. 1, 2, and 3. Ways. What's the other name for ways? Okay. And what's the third? Yeah, that's actually it. What is the method of, sorry, I didn't hear you. What you're looking at, it's not so much method for operation as method for actuation. So what you're looking at is, I guess you could call it type of let's try that again. Not so much fun, you're not talking about function. What we're talking about with method of actuation or type of actuation is how is it shifted? How are we shifting this valve to make it work in which way we're making it work. Does that make sense? So in other words, when I'm talking type of actuation, is it solenoid operated? Is it manually operated? Do we operate it with a cam or a push button? Is it pilot operated? That's what we're looking at with that, is the type of actuation. Is it how is it moved? Yeah, these are actuators, right? All the actuators are movement, right? So what type of actuators are moving the spool? Does that make sense? So that's what the question is what type of actuation? What is moving the spool inside it so that you can change the position? Okay? Any questions on that? In this, huh?
We use air to move that one, right?
We're using air to move this one, but most of ones we use that are part of our directional control valves, you see a lot of manual types, push buttons, switches, foot levers, things like that. You see solenoids, you see cam operations or some mechanical operation, or something comes out and pushes it. You also see a lot of pilot actuation or pneumatic operation. It depends kind of on the system and what you're actually trying to get the system to do, as to what kind of valve you'd be using. That makes any sense? If you have a totally pneumatic system, you might have a smaller pressure that goes out and is able to put signals to everything. If you're dealing with hydraulics, there's about 1,000,001 different systems you can set up for that, for any of this. Okay. Now then, let's talk about, like I said, I have recently gone through test 1 and made sure it's good for our first test. There's going to be some matching on it. And as far as what in heaven's name? I just corrected all this, and what is going on? Okay, some of the stuff didn't get deleted. That's what that is. Okay. Sorry about that. I'm going to have to go back through it again, apparently. So some of it is going to be actual mathematical problems. I have changed all these to multiple choice questions. So to start with, let's kind of review with this. This should look familiar from whenever we were doing our first lecture. That is really crappy right there. Okay. When we're talking about hydrodynamics and what? What were some of the things we were talking about with hydrodynamics? You gotta be kidding. All right, so hydrodynamics. What is the great thing about hydraulics is that we can do what? Is that I can use something really small to move something big. So if I gave you the diameter of this as 1.78 inches, and this is 4.37 inches, and we've got, we'll say 50 pounds here. Let's talk about how to solve this for everything we would need to solve it for. Okay? So first of all, so one of the things you'll find is force out for a question like this. But what do we need to find first before we can find anything to do with this particular set? All right, guys, so what is our formula? We have force area times pressure. What is one of the easiest ways to find area? Is it 7 or is it? 785. That's not r squared, it's d squared. We have two formulas that we use with this particular type of problem. You have your typical force is equal to area times pressure, and then you have area equals d squared times 0.785. I don't know why it's doing that. So first of all, do I have my area on either one of these? That is not the area, that is diameter. No, I don't. So what do I need to do? Okay, so I have to find the area. So I would say 1.78 squared times 0.785. Correct? Everybody following? Everybody understand? Anybody got questions? All right, when I hit enter on that, my area total 2.49 inches squared. You're If I can give you what? What did you put in? .78 squared times 0.785. It might have rounded it off for you. So before we do the next one, is there any way to get rid of this stream memory thing? Nope, apparently not. Nope, that's your force. But where you need to go ahead and find the area of our other set over here before we do that. Squared. So you find 4.37 squared and then multiply it by 0.785 and it gives you, we'll round that up to 15. 15 inches squared. Okay, everybody following me all right? Any questions from anybody? Okay. So now here's where we have to start taking into account our 50 pounds. So this is a closed system, which means my pressure is what? No, your pressure is equal throughout. So my pressure for this cylinder over here will be the same as my pressure for the cylinder on the other side. It's not 50 pounds of pressure, it's 50 pounds of force that's putting it on that piston. Does that make sense? You're putting 50 pounds of pressure on a piston. So, in other words, if you're trying to lift somebody using a car jack, you have 50 pounds. How much pressure am I putting into the system and how much is it able to lift? So you do force divided by area to get pressure. So it literally should be, drag this over a little bit, 50 divided by 2.49. And I should have 20 psi. Now, what the funny thing about that 20 psi is it doesn't just stay over here, it travels over here. Why? Because it's a closed system. Okay? Bring the calculator back. So now what we're going to do is take 20 psi, multiply it by 15 inches to get 300 pounds. All right, so let's talk about what this actually means for everybody. What this means is that for every 50 pounds of pressure, 50 pounds of force you apply to piston 1, we'll call this guy right here piston 1, and this guy piston 2. So every 50 pounds of force you're putting into piston 1, you're generating 20 psi. With that 20 psi, you're lifting 300 pounds at a time. Okay? Does that make sense? Because I guarantee you there will be this exact question with different numbers on the test. And you will be asked to find most, if not all, of this in several different questions. You will have the formulas. I will make sure they are provided. They're actually in your book. The little fluid power data book I said y'all could use. But we'll go ahead and for this test make sure that they are up on the board. Okay. There will be probably 4 questions at least with these in it. And up until now, I have not done this as anything but a short answer. However, you would not believe how many times I tell people I only want the numbers, and they'll still try and put 300 lbs. And believe it or not, this thing does not like problems like that. It detests them. I don't know why. Because every time I get done with a test, everybody sits there and goes, Ms. Bush, I don't think I did very well because it just came back and it said I only got 3 questions right. Okay. I go through all of it and have to give points back, make sure other points are taken. So we're going to try a more streamlined process this time, whereby I give y'all a multiple choice test instead. Okay? All right. So there's going to be several questions with force, area, and pressure. I can only suggest that y'all work a few problems with that and make sure you go over your notes for that. Okay? Another thing you need to do is make sure you know the difference between PSI A and PSI G. What is PSI A? True zero, PSI G. So if I give you, let's say, I actually need to do that on the computer too. All right, so I'm going to erase all this, guys. We're going to move on to another question real quick. Okay, and that's still there. All right, there we go. So if I give you 300 PSIA, what is PSIG? So first of all, what is the difference between PSIA and PSIG? You're going to subtract 14.7 PSI. Why? Because A is absolute 0. G compensates at 14.7 psi. Should be 285.3. How did we get that? How did we get there? (300 minus 14.7), yeah. Everybody following? Everybody understand? All right, what about if instead it was 300? You had 250. PSIA, what do you get for PSIG? Does everybody agree with that? (235.3). Okay. Everybody understand where all this came from? Okay. Any questions on that, guys? All right. That is the majority of what will be on your test, other than some matching, guys. It's all going to deal with force is equal to area times pressure, and you will have to be able to find area in several cases. Okay. Test 1 will be Wednesday, just so we can go ahead and get it out of the way, unless y'all, because if we don't, we're going to start covering new material. And then that'll really get you confused for test 1. So, for the rest of class today, I'm going to let y'all go ahead and go to lab. Everybody good with that? All right, then that is what we shall do. We will go ahead and go to lab for the afternoon. If you have any questions, let me know.
So, Ms. Bush, you about to go to lab now?
Yes.
Okay.
Yes, it's just down the hall.